So this video is based on the sample material produced by OCR for the specification A Physics and it's a breadth in physics. And in the description below, I've linked to the actual paper, which includes a mark scheme within it. So basically, you shouldn't be watching this until you've actually seen the paper, you've had a go yourself and you've really tried. So this is very much my walkthrough for it, and this is the way that I approach the answers. So first of all, the first bit, the first 20 marks, which should take you about 25 minutes, are the multiple choice questions. So the first one asked you to look at the percentage uncertainty, so straight in with something based on the kind of practical side of the course. And it's about the density of the sphere. Well, density is equal to mass divided by volume, and volume is equal to 4/3 pi r cubed. So what I did was, first of all, I worked out the uncertainty, the percentage uncertainty in the mass. In this case, because it's 100 plus or minus 6, that's 6 over 100, so that's the absolute uncertainty over the measured value, times 100 to give me a percentage uncertainty of 6%. In the radius, because it's 1.6 plus or minus 0.08, that then gives us, again, an uncertainty of 5%. But in order to work out the density, it's equal to mass over volume, and effectively 4/3 and pi, these numbers here are sort of pretty fixed. We know what they are to a good number of significant figures. So that means the density depends on the mass and the radius, but the radius is cubed. So any uncertainty here, we just add it all up to get the total uncertainty. So it's 6 plus 5 plus 5 plus 5, which is 21. So the first one, the answer is D. Second question, this one here, I must say I got it wrong the first time. I didn't read the question. So first of all, you've got an object of mass 7 kilograms that's pulled upwards. It's accelerating upwards at 2 meters per second squared. So what I did was I drew it. So here is my object, doesn't really matter what it is. And basically there's two forces acting on it. You've got the weight acting down and you've got the tension pulling up. And the thing is that the tension is going to be bigger than the weight if it's accelerating upwards. So what I can say then is that the tension minus the weight gives us the net force. And that net force causes this object to accelerate. So, you know, a bit of sort of Newton's second law there. If I rearrange this, I can say that T is equal to F plus W, because we're trying to find out the tension in the rope. And therefore the tension is equal to the net force, which causes this acceleration, so MA plus the weight, which is mg. So T is equal to MA plus g. I put the numbers in and I'll find that the tension is 82.67, which is about 83, and therefore again the answer is D. And the important thing is, when I did these two questions here, I tried not to look at the answers before I did the question. Okay, if you just look at the answers, you think, well, okay, maybe 7 kilograms times 2 is just 14. And that's one of the distractors that you don't want to look at. So do your working out, read the question before you look at the answers, especially to the numerical questions. Okay, so this one here, you've got a load of different statements and you need to work out sort of which are true and which are false. Well, first of all, what I'm going to do is going to look at these. I'm going to not even look at this yet. So the net force acting on the cork is equal to the weight of the water displaced. Well, there's no net force because the thing is it's just floating in the water, and that means there must be no net force. Effectively, upwards forces equal the balance forces. So I'm just going to get rid of that first statement. The weight of the cork is equal to the upthrust on the cork. That one there is true just from the physics knowledge that I've gained. And the upthrust on the cork is equal to the mass of the water displaced. Well, it can't, because that's the force and that's a mass. And mass is measured in kilograms, so different units, so it can't be that one. So which one of these is only 2 correct? Well, again, the answer is D. So it's this one over here. Okay, so for question 4, the way I approached it was we need to find the force constant, which is K. So we know that F equals Kx, and it can be if it's being compressed or if it's under tension. I've rearranged this to get K is equal to F over X. The force is 200 newtons, that it says over here, and the extension is 0.01. So it's just 200 over that number to give a value of 2.0 times 10 to the 4. So here the answer is C. Okay, question 5 is a bit like rather than something moving up, like in the other question, it's actually moving something moving down. So again, my first approach is to draw the diagram. You've got something which is going vertically downwards with a constant acceleration, so here's my acceleration downwards. There's different forces in it. You've got the weight acting down, and in the up direction we've got the upthrust and the air resistance F. Now again, if it's moving downwards, the friction must be, the air resistance must be in the opposite direction. So I can say that U plus F are the forces upwards, weight is the force down, and if it's accelerating down there must be a net force down, which means that weight is bigger than the upthrust and the force. So again, that's what I've written down, and luckily it comes up over here, and that's again an answer of D. So it seems like D is quite a sort of popular answer at this time. This one here, lots of text, not a huge amount of pictures, so I just drew a kind of a brick-shaped object. So you've got A is smaller than B, which is smaller than C. What we can see from this is when is the pressure to maximum? Well, we know that pressure is equal to force over area. Now, if this object has a mass of m, then the force acting down, the weight, is going to be equal to mg. But what's going to be the area? Well, you're going to have the greatest pressure when the area is smallest. And the face, which is the smallest face, is this one over here. And therefore, the area is equal to AB. So that means the pressure is equal to mg over AB. And we look over here, and the answer is A. So the top one over here. Okay, 7 is pretty tricky. Basically, you've got two things which are falling. They have the same diameter. So you've got two balls with the same diameter, but one of them has a bigger mass than the other one. So the question really is, which of these is correct? First of all, looking at these, well, some of them we're maybe not sure about, but some of them we know that's definitely not true. First of all, the balls have the same kinetic energy just before hitting the ground. They both reach terminal velocity. It doesn't say how big that is. So I'm going to say that probably that's not true. If one's moving faster than the other, it has a different mass, probably the kinetic energy is going to be different. Okay, and this is because, you know, we do have drag affecting these. So that one there is not true. The terminal velocity of y is greater than terminal velocity of x. Well, this one here is effectively y because it's got the smaller mass. And what we tend to find is that lighter objects tend to have a lower terminal velocity. So that's not true. The balls hit the ground at the same time. That's not true if they have a different mass, and we're talking about real world situations here. So what is true? Well, the balls both have the initial acceleration. The reason being that when they start accelerating initially, both of them have an acceleration which is due to gravitational field strength, which is 9.81 meters per second squared. And therefore the answer to 7 is 7C. Okay, this is a nice question. It involves lots of stuff. Basically, we know that power is equal to force times velocity, so P equals Fv. We know that the force that it's pulling up with, if it's moving at a constant velocity, is going to be equal to the weight acting down, which equals mg. So we know the force is equal to mg. We also know that it has an efficiency of 20%, so eta, the symbol we can use for efficiency, is equal to 0.2. And therefore, if we put in 9.6 watts, or 9.6 joules per second, only 0.2 of this gets actually transferred into useful work out. So 9.6 times 0.2 is the power, and that's equal to m times g times v. So this is the force here times v. I put the numbers in, I find that the velocity is equal to 0.391 meters per second. So that's what I did before I even looked at the answers, and luckily that's one of them. And so the answer to 8 is A. Okay, question 9 was really tricky. I was looking at it with some of the other physics teachers and my year 13 students who are, you know, kind of A-star grade students. They weren't getting the answer either. So my approach is, first of all, we're going to ignore the guesses. So we might guess if we sort of didn't have enough time. It's basically, it accelerates it uniformly from rest along a level road. And therefore, as time goes on, the velocity increases at a uniform rate. So there's no air resistance, and the car travels 12 meters in the second of its journey. Now this one here I think is very tricky, so what I'm going to do is I'm just going to break down the velocity time graph because it's increasing the velocity like this. So what do we know? Well, we know that basically in this region here, so if this is time 0, 1, 2, 3 and 4, in this second of its journey, so not 0 to 1 but 1 to 2, it travels 12 meters. So effectively here the displacement S is equal to 12. We want to know the displacement here between seconds 3 and 4, and that is our unknown quantity. The way I did this was I looked at this graph and I thought, well, let's divide it up a bit like this. Now, if each of these is the same time interval, then they all have the same width. The distance from here to here, well, let's say that this is a box which has an area of x. That means if you've got one of these triangles, the area is equal to x over 2. So if I just fill that in, we've also got that area is equal to x, so is this area and so is this area, and then so is this, and this area in here, then the triangle is equal to x over 2. Now, velocity time graphs, the area underneath is equal to the displacement. So what we can say then is that effectively between 1 and 2, the area is equal to x plus x over 2, and that's equal to 12 metres. So that means 3x over 2 is equal to 12. So 3x is equal to 24. That means x is equal to 8. So basically this is my approach. Up here then, we want to know the distance when it goes a total of x plus x plus x plus x over 2, which is 3.5x or 7 over 2 times x, and that's equal to our unknown displacement s. If x is equal to 8, then you've got 7 times 8 over 2 is equal to the displacement, which is equal to 56 over 2, which equals 28 metres. Okay, so the answer is A, it travels 28 metres. So there we go. This one here, it got me really thinking. It took me a while to come up with this solution. Can you get that in 1 minute? We've sort of 1 mark over here. I thought that was pretty tricky. I'm sure there's different approaches to it, but I found graphically it was better than trying to use SUVAT or other things like that, because it ended up with different sorts of simultaneous equations. A pretty tricky question. Let's hope that it gives you anything like that this summer. Okay, question 10. This one here is a bit more tricky. There's different sorts of errors like random errors and systematic errors. Now the thing is, basically you're going to have an error due to the random errors just in measuring like where the start and the end point is. So maybe you've got some kind of sort of random error that just sort of happens over here. But if you're looking at the wrong angle, what you then have is a parallax error. And the parallax error is something which is systematic. So basically in this, there are both systematic and random errors, and therefore C is the correct answer. This one here you can't really do much about, it's just a small thing from the uncertainty in the measuring device. This one here is due to something wrong in your method, and it will always give you that same wrong value. Okay, 11. Which of these are true and which are false? So the speed of a photon changes at the boundary between air and glass. Well, that's true, which is why we have refraction. Photons are electrically neutral, that's true, they have a charge of 0. The energy of a photon depends only on its wavelength. Well, this is true as well. Effectively, we've got E is equal to hc over lambda. And provided photons are, I guess, moving along, we can also say that E is equal to hf. Basically, the energy of the photons really depends upon the frequency of that photon. So this third one is true as well. And which one's correct? So 1, 2 and 3, the answer is A. Okay, so question 12, you've got something which is a phase difference of 180 degrees with reference to point X. So here is point X. What I'm going to say is, well, let's look at maybe a point which is sort of 360 degrees in front, and that's going to be over here. So if you've got that 0 is at 360, what's halfway along? It's about C. The reason it can't be D is because, you know, that's kind of on this side and that's on this side, and so is this. So D can't be 180 degrees out of phase, and this one's too close. So I'm just going to say that the answer to that is C. Okay, 13. So this one here, again, let's get rid of the statements which aren't true. So which of these is, or which of them are true? So the refracted light and incident light have the same wavelength. That isn't true. What happens is the wavelength will maybe change as this thing goes into maybe a different medium. So the wavelength might change, but the frequency stays the same. So that one there isn't true, so let's get rid of that. The speed of light in medium 2 is greater than the speed of light in medium 1. Well, this one here, if you maybe think about the analogy of maybe a car moving along, if a car moves along and hits a boundary, if one of the wheels starts to speed up, that's when that car changes direction. And it's the same here, this changing direction is bending away from the normal, and therefore it's speeding up. So this one is true. Angle theta is a critical angle. Well, if it was a critical angle, then the ray of light coming in, that was when you'd have basically the refracted ray moving along the surface. And that's not happening in this case. So that one there can't be true. So which of these is only 2 correct? The answer is D. Okay, 14. This one is about the conduction of electrons in this resistor. First of all, the electrons, do they travel at the speed of light between collisions? No, they don't. Okay, they make random collisions with vibrating electrons. No, really, it's not so much the electrons they collide with, it's more the collisions between the vibrating ions in that metal lattice. So that one's not correct. They travel at their mean drift velocity between collisions. That's not true because they tend to fly around really quickly, but maybe they don't all kind of move in the same direction. So their mean velocity is from A to B, but their actual velocity instantaneously is quite quick. So that's not true. And they drift towards the positive end of the power supply. Well, that's true because their electrons are negative and they go towards the positive end, and therefore the answer to 14 is D. 15 I thought was quite a tricky question. There's lots of information here, lots of calculations you could do. So basically what we know is 60 watts is the same as 60 joules per second. Well, that means if it transfers 60 joules in 1 second, it transfers 120 joules in 2 seconds. There's lots of information there, lots to read, but I guess I sort of, knowing a small amount about this lamp and just sort of seeing that right answer, so that sort of really popped out at me. So that one there is correct. 16, again, a lot of work for 1 mark. First of all, I drew the circuit. Always do that, just to help yourself. So it's got an EMF of 8 volts, so I know that E is equal to V plus IR, so V is equal to E minus IR. So V is the terminal PD, or the PD that you get across component. E is the EMF, I is the current, which is the same everywhere due to Kirchhoff's first law, and R is the internal resistance, which I represented here with this resistor inside my cell up here. So I can work out first of all the PD that is across this external resistor, and that's equal to 8 minus 2.5 times 0.35, which equals 7.125 volts. I then said, okay, let's work out the power. Power equals I times V. We know I is 0.35, or 350 times 10 to the minus 3. Times that gives a value of 2.49 watts, which luckily is one of the things over here. So here, the answer is B. Okay, 17 I thought was a fairly straightforward, nice question. You've got the speed of sound here. You want to know the wavelength. And what this gives you is a graph with time. And again, what they're doing here is they're giving you time in milliseconds. So first of all, V equals F lambda, very furry lambs. Frequency is 1 over time period, and therefore V is equal to lambda over T. I've rearranged it to say lambda equals V times T. I put the numbers in, so 340 times the time for 1 wave cycle, which is from here up to here, so that's 2 times 10 to the minus 3 milliseconds. So 2 times 10 to the minus 3 seconds. And this gives us a value of 0.68 meters, which again, luckily, is one of our options over there. So again, do the mathematics and then check for your answers. Okay, 18. First of all, which of these are correct? Well, first of all, if you increase the EMF, then there's going to be more energy sort of per unit of charge in that circuit, and that will then also increase the terminal PD. Secondly, increasing the value of the external resistor. Oh, this is tricky. Basically, what do we know? We know that V is equal to E minus I times R. Now, basically, V is equal to E minus IR. So what that means is when you have a smaller current, this takes effectively, you have less lost volts within the cell itself, and that means you have a greater terminal PD. So if you have a bigger external resistor, that means less current can actually flow around the circuit, so the value of I decreases. So increasing the value of the external resistance actually causes the current to go down, and therefore this increases the terminal PD of that circuit. Increasing the value of the internal resistance, well, effectively, if you make R bigger and the other things are the same, what that means is that you then get more energy lost within the cell itself, so that one is not true. So one of these is 1 and 2, which are correct, which is B. Okay, 19 kind of messes with your head. So again, here's a diagram of what the wave is doing. Now, a short amount of time later, this wave is going to move like this and along. So that means a very short amount of time later, P has gone from here down to here. And therefore, P has moved downwards, which is B. Basically, if it's a string, it can either move up or down, so you've got a 50-50 chance. But this does mess with your head. The wave is going this way, so P actually moves down. And therefore the answer is B. And finally, question 20 on the multiple choice questions. So which of these can be deduced from the characteristics? First of all, the resistance is 0 between 0 and 0.7. No, it's more of an infinite resistance at that point. It's constant between 1.0 and 1.5. This is where lots of people make mistakes. Now, the gradient of an IV graph is not equal to 1 over the resistance. If you wanted to know maybe the resistance at this point here, the resistance is equal to the ratio of V over I, and that's going to be a different ratio to the value up here where it's again V over I. Effectively, it's, it does tend to be that when you have a steeper gradient, you have less resistance, but the gradient does not equal 1 over the resistance, only for a resistor. So that's not true. It's 0.4 at 1.2 volts. No, that's just rubbish, just completely wrong off that graph. And it decreases between 0.7 and 1. So here, between this point and this point, what we're looking at is the resistance decreases, because that's when current starts to flow, and therefore that's correct. And the answer is D. So in summary, some very, very tricky questions there. Not all of them were obvious, and there are many distractors. So what I'd recommend doing is, first of all, if it's too hard, move on, leave it till the end. Do the work, do your working out before you even look at the answers to kind of, don't get distracted by them. And if there's different things that you can look at, just, to get rid of the ones which are immediately wrong, and then you might narrow down your choice to one between two. So that was the first 25 minutes in total of your paper.